Hello, welcome. Let's continue the series we are doing on permutation and combination. This is episode 2. We want to try what we have done in the first episode and see how we understood the concept. So we have a license plate has two letters, which is followed by four digits. So these are the conditions on which we are finding it. First condition: if no letters or digits can be repeated, how many different license plates are possible? So this is going to be taking an account of what? Permutation. Then if repetition of letters and digits are allowed, how many different plates are possible? So if we are having a license plate which is having two letters, four digits, which means we have what? Five of number plates. All right. So if I have a six rather, right? First, second, third, fourth, fifth, and sixth. So this is what is going to be the number plate. Now, if the letters, how many possible outcomes do we have for letters? We have A up to Z. So there are six possible outcomes, meaning I can get six different ways of selecting a letter, first letter. So it means that if I have up to 26 options to pick from, so I'll be having 26. When I pick the first letter, then it means the second position, the letters will reduce to what? 25. So I'm having a sample of 25 to pick from. So I have 25. So that is all. Two letters followed by four digits, meaning counting numbers. And the digits also have what? 0 to 9. How many possible outcomes? 10, right? So in that 10, the first instance or the first place, there will be 10 numbers to pick from. So I have 10. I'll be left with what? Only 9 to pick from for the second slot. It will be left with 8, left with what? 7. So in terms of our fundamental principles of counting we did in the first episode, we can say that we have 26 times 25 times 10, 9, 8, 7. That will give us a total of what? So this will be giving us a total of 3,276,000 plates. This is what we are going to have. So you can see that in writing or generating number plate for cars, we can see that this, if we are just going to say that first two slots to be letters, then the remaining four places should be digits. We are going to have up to 3,296,000 options or variants to pick from. All right, narrowing this back to the permutation we did in the beginning, we can see that we have 26 options to pick from, or 26 different objects, but picking two of them at a time. So I should be having 26 permutation 2. That gave me this. Remember the factorial that we have. Then in the sense of the letters, we are having 10 different letters to pick from. Then we are picking only what? 4 at a time. So I have 10 combination what? 4. And this will also give rise to a total of 3,276,000. So let's go for the second option. If repetition of letters and digits are allowed, how many different plates are possible? So in this case, it means that when I pick the A, I'll be left with what? Still 26. Because A can become again. It can be AA, BB, CC. So the moment I take the first letter, I still have in the sample of 26 to pick from. So that means 26 in the first slot, still I'll be left with 26 to pick from. Do you get it? That is in terms of repetition. So all the numbers, they are all going to have equal chances of what being repeated. Then times, I have first chance for letters of 10. When I pick 0, I'll still be left with what? 10 to pick from. So I'll still have 10 times what? 10. And multiply all this together. We are going to have 6760. So it means that we have 6,760,000 different options to pick from. Now, this could also be written as 26 with a repetition of 2 times 10 with a repetition of what? 4. So this is also one way by which we can get, if the letters are going to be repeated, all of them will come back again, keep on repeating themselves. All right, I guess this is clear. If not, but we can also try and see if we can be able to put a formula to the second one, since we are only dealing with permutation. I'll be waiting in the comment section for a thought. Like, share, comment, and subscribe.